more finding roots. So yesterday I think I mentioned that I had another example like number 1, but I was going to save it for today so that hopefully you can ask me as I'm going through the process where you got stuck last night. You can ask me to explain that further, or maybe it'll help clarify things. So here is our example. Find all the zeros. F of x is equal to 6x to the 4th minus 7x to the 3rd minus 21x squared plus 21x plus 9. So here's my first question. How many answers am I looking for? 4. So whatever I do, I've got 4 answers. It looks like 1, 2, 3, 4, 5 terms. I'm going to have to use my rational root theorem. I have no other choice there. So I'm going to start off with my factors of what?
9.
Factors of the constant, which is 9. So what are the factors of 9? 1, 3, 9. Not too bad of a list. Now what I do next? Factors of what? Factors of the leading coefficient. What's my leading coefficient?
6.
So what are my factors? 1, 2, 3, and 6. So let's come up with my list of possible roots. Do you remember how I do this? I set up a fraction, and the first thing I'm going to do is I'm going to cover up the 2, 3, and 6, and I'm going to do 1 over 1, 3 over 1, and 9 over 1. That's how I start. So I have plus or minus 1, plus or minus 3, plus or minus 9. Now I'm going to put them all over 2. So 1 over 2, 3 over 2, 9 over 2. None of those reduce, do they? So they just all get added. 1 over 2, 3 over 2, 9 over 2. All right, now we got to put them over 3. 1 over 3 is not on my list yet. 3 over 3 is 1, and 9 over 3 is 3. So we do have some duplicates there. And then finally over 6, 1 over 6, 3 over 6 is 1/2, which is on my list, and 9 over 6 is 3/2, which is on my list. So this is my total list of possible roots. So? Okay, that's a long list, isn't it? How many numbers are on that list? 16, because each one is a positive and a negative, right? So I'm hoping that I'm not going to have to do synthetic division 16 times, right? By the way, just to clarify, these are possible roots, not necessarily actual roots. In order to be an actual root, it has to give me that remainder of 0. I know that I'm only going to have 4 answers, so clearly 16 numbers can't all be answers, right? In fact, there might only be 1 or 2 answers on this list because some of our answers may end up being imaginary or not nice. And we'll talk about those a little bit later. So, let's see. Should I look at a graph? Do you think that would be helpful? Now, I'm going to look at a graph the way you would look at it on a test. So, if I looked at this, hang on just a minute, Desmos. Start graphing. 6x to the 4th minus 7x to the 3rd minus 21x to the 2nd. If I type something wrong, let me know. Plus 21x plus 9. Is that correct? Now, On the test, you're not going to be able to scroll your mouse over those points like I did yesterday. You're just going to have this picture. So if I use that picture, let's say I zoom in a little bit more, I need to estimate what those are. Do any of them look like nice numbers? Not really. Do any of them look like perfect halves? Does this look like a perfect half? How about this one? Does that one maybe? Hang on, let's think about this. This is 1 and this is 2. This would be 1.5, so this is just less than 1.5, right? Okay. What about this one? This one's just less than 1/2. This one's more than -1.5. Maybe we'll try this guy first. I need something that, let's see, 1, 2, 3, 4, 5. Goodness. Okay. Make it even more difficult. There we go. Okay, zooming in more. This is obviously less than 1/2, right? It's even less than 0.4. Okay. Is there something in here that looks like it's less than 1/2? What number on here is less than 1/2? 1/3 and 1/6? Do we think it looks like maybe 1/3 or 1/6? Which number is bigger, 1/3 or 1/6? 1/3 is bigger. It's closer to 1/2, right? Do we want to try 1/3 or do we want to try 1/6? Let's try 1/3 and see what we get. Okay, so if I make 1/3 my box number. By the way, why am I going for fractions here? Because they're all going to be fractions. None of them are crossing at nice places. So that means I can basically eliminate those guys from my list, the 1, 3, and 9, because we're only dealing with fractions. What are my numbers across? 6, -7, -21, 21, and 9. Now, I guarantee you a place that messes people up is if they forget to put placeholders if they need to be placeholders, because they don't think about that. Does there need to be a placeholder? Did I make that mistake? 4, 3, 2, 1, 0. Okay. Let me go back to here so you can actually see what I'm writing down. Thank you. All right. So let's see. Yes. So we were looking to the left of 0, correct? Thank you. So let's bring down our 6. What's 6 times -1/3? 6 times -1/3 is -2. -7 and -2 is -9. What's -9 times -1/3? 3. -21 plus 3? -18, right? -18 times -1/3 is 6. 21 and 6? 27 times -1/3 is -9. There's my remainder of 0. Hallelujah. We picked the right fraction. So of my answers, I know that -1/3 is one of my 4 answers. I also had a 4th degree equation, and now I'm down to a 3rd degree equation. So 6x to the 3rd minus 9x squared minus 18x plus 27. Now, I want to go further here, and I maybe could have done this at the beginning. Well, no, I don't think I could have done it at the beginning. Can I make these numbers any smaller? How? Factor out a 3 or divide by a 3, right? Because if I factor out a 3, is there an answer there? Remember when we factored, there's only an answer outside if there's a x with it. So I can just divide everything by 3 or factor out that 3, and it's going to make my numbers easier to deal with. Oop, this is x cubed. Minus 6x plus 9. There we go. Smaller numbers. Yay. Can I use grouping here? Yes. Awesome. Okay. So if I cut this in half, what do these two have in common?
X squared.
What's left inside? 2x minus 3. Bring down my minus sign. What do these two have in common? What's left inside? 2x minus 3. Yay! X squared minus 3 and 2x minus 3. So again, all of this is equal to 0. I'm not writing that every step, but it is. So where do I go from here? Set x squared minus 3 equal to 0. I would add 3. That gives me x squared equals 3. And I square root both sides, giving me x equals positive and negative radical 3. I would have never been able to guess radical 3 off the graph. Right? And then 2x minus 3, set that equal to 0. 2x equals 3. Divide by 2, x equals 3 halves. That was another number on my possibility list. I might have guessed that one, but the radical 3's I guarantee you not. So negative 1/3, 3 halves, and positive and negative radical 3 are my 4 answers. So? Okay, let's see what I want to do next. I'm thinking... I'm going to hold off on 7.2 comes next. 7.2 is exactly the same as 7.1. The only difference is that sometimes we may get to a place where we can't factor at the end and we have to use quadratic formula. That's the only difference. So the rest of the process is the same. So I'm going to go ahead and stop here for today. I know that's a short one, but it's just one example to hopefully get you going, continuing in the right direction. Let's do some more practice of it before I start throwing in quadratic formula and imaginary numbers. Fun times. All right, happy studying.